Hey guys, today we're going through Chapter 6 on periodic functions, and we're working through Section 3 on inverse trig functions. And we're doing number 24, which says find the exact value without using a calculator. And we're given the inverse sine of the cosine of pi. So whenever we have an inverse function, what we want to do is rewrite it. And we want to say the sine of some angle gives us this number inside of the inverse. So the sine of some angle theta equals the cosine of pi. And we know from the unit circle that the cosine of pi is equal to -1. So here's our unit circle. And pi is going to be this 180 degrees. And we know that right here we've got, if all of our points on the unit circle are cosine of theta comma sine theta, we know that this point right here is -1 comma 0. Cool. So now what we want to do is find out where the sine of theta equals -1. So where this y coordinate is going to be equal to -1. And also we know from the unit circle that that's going to be this point right here where we have 0 comma -1. So now what we need to do is find out what this angle is. But there's a stipulation we have to be aware of, and that's the domain of the inverse sine. So the inverse sine is valid between the values of theta is between -pi/2 and pi/2. So whatever answer we get must be within this range. Cool. So we know that if we go from the positive x-axis, we're going to get 3pi/2, but 3pi/2 is not within this range, so we're going to have to take it from the negative x-axis, and we're going to find that our theta value is equal to -pi/2. And that's our answer. I hope you found this video really helpful. The concepts we covered in this video are true no matter what pre-calculus class you take, and the examples I cover are from this textbook right here. And remember, if you're a Baylor student currently enrolled, there is free tutoring on the first floor of Sidrich. You can create a one-on-one appointment online or drop in anytime during our business hours. Please visit our website, www.baylor.edu/tutoring, for more details. Sic 'em Bears.